again I'll tell you. We are going to see about the Thomson construction. Before dealing with the Thomson construction, there is a connectivity between the regular expression, NFA with epsilon transition, NFA as well as DFA. I told you earlier. So all the regular expressions can be converted to NFA with epsilon transition. Similarly, all the NFA with epsilon transition can be converted into NFA without epsilon transition. Similar way, all the NFA without epsilon transition can convert it into DFA. Then DFA is converted into regular expression. So remember that there is a relationship between the NFA and regular expression, DFA and regular expression, DFA and NFA. All these things are interconnected. All are interconnected things. These all are the interconnected things. You know the difference between the NFA and DFA. I already told it. So construction of NFA from a regular expression. This is the methodology. Input is the regular expression and output is the non-deterministic finite automata. In the epsilon construction, we are not bothering about the deterministic finite automata. Here the output is the non-deterministic finite automata. So process this one. Initially, all the strings are divided into substrings. Parsing includes consequent substrings, and there exists rules for each and every combination. You follow that rule. First one is for the basic expression, epsilon. We can draw the NFA for epsilon also. This is the NFA for the epsilon. It will goes to the final state without accepting any string. So this is the solution for this. Construct the non-deterministic finite automata. Remember that only the non-deterministic finite automata contains the epsilon. In the deterministic finite automata, there is no epsilon path. Determined path is there. This or that concept is not there in the deterministic finite automata. So in the non-deterministic finite automata, only epsilon is available. So this is the NFA that accepts the null string. Okay, null string. Epsilon is accepted by this NFA. Suppose if you want to draw the DFA for this one, only one state is enough. This is the DFA. Q naught. This is the DFA that accepts epsilon. Nothing. Nothing is there also. It will indicate there. This is the deterministic finite automata. And for each and every sub-expression, there is some rule. This Thomson construction, if for the single symbol, this is the rule. This one is the rule for the single symbol. A is the single symbol. It can be processed by the initial state as well as the final state. This one is indicated like this one. For any symbol B or 0 or 1, this kind of NFAs can be constructed. And suppose S and T are two sub-expressions. Initially, all the expressions divided into two sub-expressions. S and T are the two sub-expressions such that S plus T. The format of S plus T. In this situation, first draw a NFA for S. This is the NFA for S. And then draw the NFA for T. Here, it will follow either this path or that path to indicate that we are connecting this with the help of the epsilon. Any number of epsilon can be added in the non-deterministic finite automata. Basically, in the Thomson construction, you can add any number of epsilons. Here, this is the path. This one is the circuit. This one is the NFA that accepts. This is the NFA that accepts S plus T. Similarly, you will draw the NFA that accepts ST. ST means concatenation operation. So S followed by T. In this one, once again, I am telling you, in this one, first it starts from ST. You know that ST is not same as that of the TS, because in the ST, first string S is processed and T is processed, whereas T is T followed by S. Both are not same. So ST means first draw the NFA for S and then draw the NFA for T. Combine these two. Initial state of ST is the initial state of the newly constructed NFA, and end state of the second one, that is the end state of T is the end state of the newly constructed NFA. And same way you'll draw this for the S star or the closure also. In this closure, first draw the A means first draw the automata for A or whatever it may be. It may be a single symbol or it may be A plus B or A star B, anything. You construct the non-deterministic finite automata for the given substring. Then A star. Star means here you connect the first state and the last state of the newly constructed NFA, and you should generate a separate path that will indicate epsilon, because star, what is the meaning of star? Clean closure. It will accept the language without any string. That is also possible in the case of star. So for indicating that, for that path, we are creating this one. So it will accept any string without this epsilon also. Now you can say, oh, how can you draw A star? A star. How you draw A star? To draw A star, what is the first step? Draw A. This is A. Okay, this symbol is the A. This symbol is A. Then star. Star means repeatedly. Repeatedly, you should process this one. So this is for repetition. Then A star means without this also, it will accept something. Without this also, this will accept something. So I am creating two more states with the epsilon transition, with this epsilon transition, and from here also I'll make a path for this final state. Consider that this is the final state. This one is the final state, and this one is the initial state. For this one, the path is created. So A star means either it may accept A through this one, or any number of A's by using this loop, and without A also it will process. These are the certain things used in A star. Same way, instead of A, it may be a combination of AB or AB star, anything. For anything, you can draw this NFA. So we'll see one problem. Construct an NFA for R equal to, listen, in this class, tomorrow's class, we are going to solve this one. NFA for R equal to A slash B the whole star A. Based on R principle, first find the consequences and divide it into substring. It can be divided into two substrings. Say what are the substrings? First is the first substring A slash B the whole star. This is one substring concatenated with A. This is the another substring. Two substrings are there. First, we are going to draw the NFA for this one. Again, this is the new expression. It can also be divided into substrings. What are the substrings in that? A is a substring. A is the substring. Then B is the substring. Then find this. A is the substring, B is the substring. Then what is the next one? A plus B. Draw the figure for A plus B. Then A plus B the whole star. After completing this one, draw it for A plus B the whole star. Then separately for A, we know that, combine that one to get this one. First, you should draw the NFA for A. Take A. Here I have drawn the NFA for A. This is the NFA for B. Then I want the NFA for B. So here I have constructed NFA for AB. And based on our requirements, the next one is the A plus B. Here the single symbols A or B. A plus B. Then it will be connected with the help of the epsilon transition. It will be connected with the epsilon transition. Okay, any number of epsilons are possible. So I'll do this one. This is the NFA for A plus B. We follow either the path A or path B. A or B. So A or B. The next one is A or B, or A plus B the whole star. This is for A plus B. I need the whole star. Repeatedly I want to do this one. So I'll do this one. Repeatedly I want this one. Without this also it will process. So I'll add two more states and draw here for epsilon. That is also possible. So that is the thing for A plus B the whole star. The whole star means two loop, forward loop as well as the reverse loop. And finally, A slash B the whole star into A. Here finally A is concatenated. You know that A is concatenated with this one. After completing everything, you need name for each and every one. And finally, draw the final state also. This is the way you should construct the non-deterministic finite automata from the regular expression. And this method is called as the Thompson's construction. Let's see one example. Now I am going to construct the NFA for the given expression. For example, the given expression is the given expression is A plus B into plus AB the whole star. Now I am going to construct the NFA for this one by using this Thomson construction. So we are going to solve this one by the Thomson construction. What is the first step? First, divide it into the sub-expressions. The first one is divide it into the sub-expressions. So I'll divide it into sub-expressions. A plus B, and another sub-expression is AB the whole star. Draw the NFA for each and every sub-expression separately. The first one is the A plus B and AB the whole star. First, take the first part. In this first part itself, divide it into A and B. AB, then the addition of these two. We are going to perform this addition operation for this one. So I am going to A plus B. How you draw? First, draw the NFA for A. This is the NFA for A. Okay. This is the NFA for A. Then draw the NFA for B. This one is the NFA for B. A and B. What is the next thing? The next one is A plus B. So A plus B. A plus B means, how will you solve this? A plus B, we know A and B. Then A plus B means A plus B the whole star. So first A, this is A, and we know that plus B. A plus B, and connect these two with the epsilon. Connect these things with the epsilon. Epsilon, epsilon. This is also epsilon, and this one is also. This is the figure for A plus B. And next one is AB star. Next one is the AB star. How can you draw AB star? How you draw A? A means again this is A. This is A. Again the next one is B. This is the concatenation. So AB. The next is AB star. Star means self loop. So self loop. And star will accept the things without the final state also, that without this expression also. Hence we'll draw epsilon here. So here this is epsilon, and this one is also. This add one more thing, and this one is also epsilon. This is also epsilon, and this is epsilon. So this is AB the whole star. Now you know AB as well as AB the whole star. Then our expression is A plus B into plus AB star. Okay. Hence, in this example, this is okay. This is the first sub expression, and this one is also okay. This is the second sub expression. Then you should add these two. You should find this plus symbol. Plus symbol means either this or that. If you join these two, then that is the concatenation. That's wrong one. So it will follow two paths, either this path or that path. To indicate that, how you draw that? If A plus B and AB star the whole star. First to draw A plus B. A plus B. This is A plus B and plus AB star. AB star, I am going to draw the AB star. A, B, self loop, AB star, indicate the star, two more symbols are added, and here you draw this one. Here the symbol is like this one. Remaining place are epsilon. This is epsilon, this is epsilon, this is epsilon. This one is also epsilon, this one epsilon, this one epsilon, and this one epsilon. This is A plus B, and this one is AB the whole star. Then our example is A plus B into AB the whole star plus. So again you concatenate these two things with the epsilon. Here also join these two things with the epsilon. Now this is your initial stage and this one is your final stage. Now this is the diagram for A plus B. A plus B in plus AB the whole star. That is, it will follow either this path or that path, this one or that one. Hence, it can be accepted. A plus B the whole star. This is A plus B and plus this is AB star. AB star. So this one is the diagram for A plus B plus AB star. Same manner, you will create the diagram for the given string. So okay, I will give this in the next class.